So this video on probability is going to be looking at mutually exclusive events, what they are and how we can work things out with them. Okay, so first thing is, what are mutually exclusive events? So it's events that can't happen at the same time. Okay, so the mutually exclusive, they can't happen at the same time. For example, let's say I had this six-sided spinner and I said, okay, I know that it cannot land on 1 or 3 at the same time. It's impossible. So if I spin the spinner, they cannot happen at the same time. So that is what we call mutually exclusive events. So when we have two events that can't happen at the same time, if we want to work out the probability of one of them happening, we connect it with the word or, which makes sense. One happens or the other. And when we find the probability of mutually exclusive events, we add the two events together. Okay, so that's from previous videos how we write probability. So let's have a go at an example using this spinner. So let's say Isla is going to spin the red spinner. Find the probability of the following. So the first one, it lands on a 2, a 6 or a 2. So the mutually exclusive events, they can't happen at the same time. So the probability of it landing on a 6 is 1 out of 6 because there's 6 different numbers. The probability of it landing on a 2 is also 1 out of 6. So the probability of it landing on a 6 or a 2 is I would just add these two probabilities together. When I have fractions, I just add the numerators together. So this becomes 2 over 6, which I can simplify to a third. So the probability of it landing on a 6 or a 2 is a third. Okay, we can write probability as percentages, fractions or decimals. This is just easier to write as a fraction. Right, B, what's the probability of it landing on 3 or an even number? So they can't happen at the same time because 3 is not even. So the probability of it landing on a 3 is going to be 1 out of 6. There's only one of them. An even number, we have 2, 4 and 6. So there's 3 out of 6. So the probability of them both happening is we would add them together. So we add the numerators, we get 4 over 6, and we can simplify it, which is going to be 2 over 3. So that's the probability of it landing on a 3 or an even number. Okay, so it's greater than the first one. Right, C, what's the probability of it landing on a 3 or a multiple of 3, or an even number? Okay, right, now here's a problem. A multiple of 3, we can have 3, 6, and an even number, we can have 2, 4, and 6. If you notice, 6 appears in both of them. So these are not mutually exclusive events. So we would not use the rule we have just used before. We would just maybe list all the outcomes. Okay, and you can't double count the 6. So I have one outcome, which is the 3. I have two outcomes, which is the 6, so you can't double count them. So 1, then we have 2, 3, 4. So the probability of it landing on a multiple of 3 or an even number is actually 4 out of 6, which we can simplify to 2 over 3. Okay, the reason I put this question in here is because we can't count the double 6, they're not mutually exclusive. And it makes sense because probability should add up to 1. So if I change that question and said, what is the probability of it not landing on a multiple of 3 or not an even number, the only two possible outcomes we could have is 1 and 5, which would mean 2 over 6, which would simplify to 1 over 3. So the probability of that not happening is 1 over 3, which makes sense because probabilities add up to 1. If I added them two fractions together, we would get 3 over 3, which is 1. Okay, so mutually exclusive events, they can't happen at the same time. Okay, so what we're going to look at now is how we can take this information and go in a table. So we have Denny has a biased dice. The probability of it landing on each number is shown in the table below. So we have 1 to 6, so that's the score he can get, and the probability at the bottom. And we notice that there's a missing number. Well, we know the probability has to add up to 1, which means if I add all my probabilities together, I should be able to work out what my missing number is. So if I add them together, I'm going to have 0.15 plus 0.25 plus 0.2 plus 0.1 plus 0.15. I'm going to call this x for now because it's an unknown number. We don't know what that is, but it has to equal 1. So if I add the numbers that I do know, so 0.15 plus 0.25 is going to give me 0.4. Add 0.2 is 0.6. Add this is 0.7, 0.85. So 0.85 plus x equals 1. So that means that missing value here, which is the probability of 5, has to be 0.15. So the probability of it landing on a 5, which is the missing number, is 0.15. So now let's look at the following question. So the first one, what is the probability of landing on a 5? Well, we've just worked that out. It was the missing value because remember, probabilities add up to 1. The second question, what is the probability of landing on a 2 or a 4? So remember, mutually exclusive events, they can't happen at the same time. We're going to add them together. So 0.25 plus 0.1 is going to equal 0.35. And the last one, what is the probability of it not landing on 1? So you can either add up all the probabilities of 2, 3, 4, 5, 6, or because we know probabilities add up to 1, we can just take away 0.15 from the actual 1. So 1 minus 0.15, and the answer is going to be 0.85. So that's looking at mutually exclusive events in a table. So probability adds up to 1, and we could easily work out what the probability of 5 was. Right, let's have a look at one more question. So we have been told that A and B are mutually exclusive events, so they can't happen at the same time. The probability of A is 0.26, and the probability of A or B is 0.64. The question wants us to work out what's the probability of it not landing on on B. So I need to work out what the probability of landing on B is going to be. Well, I know the probability of this is the probability of A plus the probability of B because it's told me that they're mutually exclusive. I know that the probability of A is 0.26 and I'm trying to work out the probability of B. So if that equals 0.64, I can just subtract that and I get the probability of B happening, even though I don't know what that is 0.38. So this is the probability of B happening, but the question wants to know what's the probability of it not happening. Well, again, I know that probability should add up to 1. So there could be other events in there because 0.26 and 0.38 don't add up to 1. But I know probabilities add up to 1. So I can just say, well, 1 minus the probability of B happening is going to give me the probability of it not happening, which is 0.62. So 0.62 is the probability of something else happening, so not B.